Hey, what's up, guys? Welcome back to my YouTube channel. I'm Mohit Kashyap, studying in SVC College of Engineering. I'm from Electronics and Communication Department. Today, I'm gonna teach you guys about a topic: scattering matrix for H-plane T-junction. Okay, this is really very simple problem. Just like we have to follow a really like three to four procedures and learn it in a snap. Okay, this is a really easy problem, so let's get started with. So moving on to the next slide. Okay, so what is a waveguide T? So a waveguide T is a three-port device that can be used to either divide or combine power in a waveguide system. It is found when three waveguides tubes are connected in the form of English alphabet T, which is either its name is derived from. There are two types of waveguide Ts: H-plane waveguide T and E-plane waveguide T. Like it's in this shape, T shape. Okay. So there are two main types of waveguide T, which is like H-plane waveguide T and E-plane waveguide T. So moving on to our next slide. So let's learn about H-plane waveguide T. So when the axis of the side arm of the waveguide T is parallel to the flow of the magnetic field from port 1 and perpendicular to the flow of the electric field, then a T is called H-plane waveguide T. Okay, so just look at the diagram when I'm explaining things. Okay, you guys will relate it. Okay, and H-plane waveguide T's can be thought of as a two-way in phase power divider or combiner. That is, it is additive in nature. When two input signals are fed to port 1 and port 2, the output of the port 3 is in phase and additive. And when the input signal is fed to port 3, the signal is split into two equal parts that are in phase at port 1 and port 2. So moving on to our next slide. So what is a scattering of matrix? So an H-plane T junction is formed by attaching a simple waveguide to a rectangular waveguide, okay, which already has two ports. The arms of rectangular waveguides can make two ports called collinear ports, that is port 1 and port 2. While the new one, port 3, is called as side arm or H arm. This H plane T is also called as shunt T, okay? Shunt T, just like ginger in Kannada, okay? Shunt T. As the axis of the side arm is parallel to the magnetic field, the junction is called H plane T junction. H plane T junction. It is also called as current junction, as the magnetic field divides itself into arms. The cross-sectional details of H plane T can be understood by the following figure. Okay, just look at the figure below. You guys will understand. So let me explain you about the characteristics of H-plane T junction. So because of plane of symmetry, power fed into port 3 gets equally divided into between port 1 and port 2. So we're gonna write, let me show you, we're gonna write S31 is equal to S32. Okay, so S31 is equal to S32. So both are same because the power from port 1 and port 2 is divided into equally. Okay, let us assume, no, so let me erase this thing. Okay, so second point is, let us assume port 3 is perfectly matched, then S of 33 equals 0. So when a port is perfectly matched, it is equal to 0. So it is given the value 0. So moving on to the third point, from symmetric property Sij equals Sji. So this is a symmetric property. This thing over here is a symmetric property in a matrix. So Sij equals Sji. So you have to by heart this formula, okay? So matrix is given by, so this is a standard matrix. So standard matrix M, sorry guys, this is a standard matrix M cross N. So let me erase this. So because S21 equals S12 and S23 equals S32 equals S31 equals S13. So we have modified this matrix a little bit, okay? So the original value of this matrix is S11, S12, S13. Here S21, S22, S23. Then here S31, S32 and S33. As we all know that S33 equals to 0 and S21 equals to S12 and S23 equals to S32 equals to S31 equals to S13. So all the values wander around, revolve around S11, S12 and S13 itself. So from unitary property, okay, so from unitary property we define that the matrix of S into matrix of S convolution. Okay, this is like just like a mirror image matrix. Okay, S matrix into S convolution matrix equals to U. U is an identity matrix. Okay, just let's consider it as an identity matrix. So moving on to our next slide. So here we have to perform matrix multiplication. Consider row 1 and column 1, R1, C1. So let me show you row 1 and column 1. So R1 and C1. So let's consider this as a matrix. Okay. Okay. Let me just select another color for marker. Okay. This is our matrix. Okay. Okay. This is a two matrix. Okay. We have to multiply it. So row 1 is the first row multiplied by C1, column 1. So when we multiply the elements of row 1 into column 1, what we get is S11 into S11 asterisk, S12 into S12 asterisk, S13 into S13 asterisk is equal to 1. So this becomes S11 the whole square, S12 the whole square plus S13 the whole square is equal to 1. This is our fourth point. Okay. So consider row 2 and column 2. Next problem is we have to multiply row 2 by column 2. Here we get S12 into S12 asterisk plus S22 into S22 asterisk, S13 into S13 asterisk is equal to 1. So the answer is S12 to the whole square plus S22 to the whole square plus S13 to the whole square is equal to 1. Now consider row 3 and column 3. Now if we while consider row 3 and column 3, we get S13 into S13 asterisk, S13 into S13 asterisk plus 0 is equal to 0. As we all know that S33 is equal to 0, so 0. So S13 the whole square plus S13 the whole square is equal to 1. So 2S13 the whole square is equal to 1. So we bring 2 to the right hand side and we shift the power to the right hand side. So it becomes S13 equals 1 by root 2. Moving on to our next slide. To get the fourth equation, consider row 2 and column 2. What they're saying is to get, we have already got three equations. So to get the fourth equations, we have to what we have to consider is, sorry guys, just give me a second guys, after I erase this thing. Okay. Okay, as we have already got three equations. Fourth equation, what we have to consider is row 3 multiplied by column 2. Okay, this looks like the shape of the T. Okay, so so what we get is S13 into S11 asterisk plus S13 into S12 asterisk equal to 0. Compare equation 4 and 5. Then when we compare equation 4 and 5, what we get is S11 equals to S22. From equation 7, S13 into, from equation 7 we are going to take S13 as common. Okay, from this above equation, let me show you. From this above equation, we're going to take S13 as common. When we take S13 as common, S11 the asterisk plus what we get is S13 into S11 asterisk plus S12 asterisk is equal to 0. So as we all know that S12 asterisk is equal to minus S11. So we're gonna bring this S13 to the right hand side. So when we bring S13 to the right hand side, it is multiplied by 0. Hence, all we have left with is we have been left with S12 S11 asterisk plus S12 asterisk is equal to 0. So we bring S11 asterisk to the right hand side. So S12 asterisk is equal to minus S11 asterisk. So S12 equals minus S11. So this is considered as ninth equation. Using ninth equation and sixth equation, four equation, we are going to find another equation, which is S11 the whole square plus S11 the whole square plus 1 by root 2 the whole square is equal to 1. So these two become 2S11 the whole square, and we bring this towards the right hand side. Here it becomes 1 by 2, okay, and 2 we cancel over here. 2 and 2 is cancelled out. 2 and 2 and 2 is cancelled out. All no, sorry guys, we don't cancel out 2 and 2 here. We multiply 2 and 2 here indeed. 2 and 2 is multiplied over here. So S11 equals root of 1 by 4, which is S11 equals 1 by 2. Now, from the above equation, we can assume that S12 equals minus S11 equals minus 1 by 2. S22 equals S11 equals 1 by 2. S11 equals 1 by 2. S12 equals minus 1 by 2. S13 equals 1 by 2. S22 equals 1 by 2. So all the values mentioned in the above, we have to like put in the below matrix. Okay, the matrix we have taken in the beginning, all the values we have obtained in the above equation, we have to like put it in the matrix. So when we put it in the matrix, this is how the matrix looks like. This is how the matrix looks like. So moving on to our next slide. So here we've come to a last round where we have to use the formula matrix of B equals matrix of SH, matrix of S subscript H into matrix of A. The matrix of B is a linear 3 cross 1 matrix. It is a 3 cross 1 matrix, while S of subscript H is a 3 cross 3 matrix, and A is as well even A is a 3 cross 1 matrix. So now we have to multiply. So B1 is equal to row 1 into column 1. So we have to multiply each row with a column 1 and get the equation. Get this equation. Now let P1 equals output of microwave power coming out of port 1. P2 equals output microwave power coming out of port 2. P3 equals input microwave power applied at port 3. Then P3 equals P1 plus P2 is equal to 2P1 is equal to 2P2. Ratio of powers P1 and P2 expressed as 10 log 10, 10 log of base 10 P1 by P3 is equal to 10 log base 10 P1 by 2 P1 is equal to 10 log base 10 1 by 2, which is equal to minus 3 dB. 3 dB down power comes out of port 1 and port 2 when power is fed into the HR. So thank you guys. I hope you guys enjoyed my video and really understood something. So thank you guys. Have a great day or good night. Signing off, guys.